Let n greater than 1 be an integer. Let pi n denote the number of distinct prime factors of n, and let xn denote the final digit of n. For example, pi 8 equals 1 and pi 6 equals 2. Which of the following statements is false? Wait, I don't understand their example. Oh, pi 6 equals 2, of course. And xn is the last digit. All right. So we have 5 statements here. I suggest we just go through them one by one and try to argue which ones are true and false. Okay, so statement A, if pi n equals 1, there are some values of xn that mean n cannot be prime. So pi n equals 1 means there is one prime factor. So n is a power of a prime. Then there are some values of xn that mean n cannot be prime. Okay, let's think for a second here. I mean, I think if xn is equal to 8, does this work? So suppose I say pi n is equal to 1 and xn is equal to 8. Then I claim that the number n cannot be prime. In fact, I think this is pretty obvious. This implies if the last digit is 8, then n is divisible by 2, which is a prime. And because pi n is equal to 1, this must mean that n is equal to 2 to the power of k for some value of k. There's only one prime factor of n, and the last digit is 8, so it must be divisible by 2. So we have this. This shows that k must be greater than or equal to 3, right? If k is equal to 1, then that's a contradiction. If k is equal to 2, it's a contradiction. If k is equal to 3, it satisfies this, but immediately, whatever value of k is, n is not a prime. So statement A is true. We're looking for the false statement, remember. Let's go to statement B. Pi n is equal to 1, there are some values of xn that mean n must be prime. Okay, so this again implies that n is equal to some prime p to the power of k. So is there a digit that a number can end in which forces k to be equal to 1? I mean, if xn equals 1, no. For example, we could have, n could be 3 to the power of 4, which is 81. If xn equals 2, no, 32 is not a prime, and it satisfies both of these. If xn is equal to 3, so if the last digit is a 3, is there a power of a power of a prime greater than, where k is greater than 1 that ends in 3? Probably, right? 3, in fact, 3 to the power of 5. That's equal to 81 times 3. The last digit is 4. then no, right? 64 is a power of 2. 64 is not a prime. The last digit is 5, 25. Last digit is 6. Well, if the last digit is 6, then the number is divisible by 2. And it certainly cannot, and it therefore has to be a power of 2 greater than 2. The last digit is 7. I don't think so. So what's the 7 times tables? 7 times 7 is 49. 7 cubed is, well, I don't know. This will eventually loop back to 7. Whatever this is, it'll eventually, increasing powers will eventually lead back to 7. If the last digit is 8, then it definitely can't be a prime that ends in 8. And if the last digit is 9, maybe that's it. No, I don't think so. If x of n equals 9, we could have n is equal to 3 to the power of 6, because that's equal to 81 times 9. Yeah, so I think B might be false. That might be the correct answer to the question. But let's look at the other options and see that they're all true. If pi n is equal to 1, there are values of xn which are impossible. Yeah, 0. So if pi n is equal to 1 and xn is equal to 0, that's not possible. So remember, n is strictly greater than 1. If xn is equal to 0, then n is a multiple of 10, which means it has at least 2 prime factors, namely the numbers 2 and 5. Okay, so there are some values of xn which are not possible. So statement C is true. Look at statement D. If pi n plus xn is equal to 2, can't tell if n prime. Yeah, so basically what I have to do to show that this statement is true is come up with values of n such that for some value of n, this is true and n is prime, and for some value of n, this is true and n is not prime. If n is equal to 10, this is true because that's equal to 2 and that's equal to 0, and n is not prime. So let's see if we can find a prime number where this is true. 81. So pi n is equal to 1. The only prime factor is 3. And xn is equal to, oh wait, that's not a prime number. Can't tell if n is prime. I need a prime number where this is true. 11. So pi of n is equal to 1. There's only one prime factor of 11. And xn is equal to 1, of course. So this statement is true. And finally, if I look at statement E, if pi n is equal to 2, all values of xn are possible. Okay, so what I want to do here is just come up with a list of numbers that have 2 prime factors and end in any digit. Okay, so 0 is easy, right? N equals 10. Ending in a 1, 21. Right? 21 is the factor of 2 primes. 21 is a multiple of 2 distinct primes. Ends in a 1. So how about ending in a 2? 22. works. Ending in a 3, 33. Ending in a 4, 14 works. Ending in a 5, 15 works. Ending in a 6, 36 works. Right, 36 is divisible only by the primes 2 and 3. Ending in a 7. Does 57 work? No. 57 is 6 times 19. Okay, something that ends in a 7, which is a product of, which only has 2 distinct prime factors, 27, 37, 47, 57, 67. Oh, 77, of course. 8 can be done with 18. And 9 can be done with 39, 13 times 3, right? So what I have here is a list of numbers, all the numbers in parentheses. Let me include a 10 up here. All the numbers in parentheses have pi n equal 2. They only have 2 distinct prime factors. And they end in all the digits, 0, 1, 2, 3, and so on. So statement E is also true. So I have that statement B is false. And I mean, I didn't do that in the most clever way. I basically brute forced it. I considered, I basically exhausted all the values that xn could be and showed that it doesn't, that the value n doesn't always have to be prime. So that's my answer. I hope I didn't make any mistakes here, but if I did, I'll write something down in the description. Thanks for watching.